In question number 55, we have a 6-volt battery with negligible internal resistance. Is connected across a uniform wire. You can consider this wire of length 60 centimeters to be a kind of a resistor which is uniformly distributed resistance across the length. The positive terminal of another battery of 4 volt and internal resistance 1 ohm is joined to point A here, and then take the potential at B to be 0. We need to find out what are the potentials at point A and point C. So let's do this first one first. What is the potential at A compared to B? So now let's say in this condition what is happening? Because of some resistance between point A and B, a current starts flowing, and all the current flows through AB and come back to this volt battery. The current tries to come here, but this circuit is not closed. There is no current flowing in this branch. That means there is no voltage drop across this 1 ohm resistor. Now with respect to B, A is at higher voltage because that is how the current can flow through this. And the A has to be at voltage 6 volt higher than point B, because that's the only way the current will flow. And obviously battery positive is here, the current will flow into this direction. So the voltage at A is going to be 6 volt, and this is because no current flows into it. Now coming to the second question, the voltage at point C with respect to B. So from here to here we get 6 volt, and then from with respect to this 6 volt, as we go through this, we have a, you can think of this battery, or you can say this trace, 6 volt, you get another voltage battery, positive is connected with positive. There is a voltage drop from 6 volt to 2 volt because of this battery. And now this point is open, so there is no voltage drop across this 1 ohm. So the voltage at C is going to be 2 volts because there is no IR drop here. So anytime you have a circuit that does not show, that is open circuit, you can neglect the drop on the resistor and it will read the voltage at C as 2 volt. Now in part B, we are asked at which point D of the wire AB the potential is equal to the potential at C. We now know that the potential at C is 4, so essentially 4 volts. So essentially we are asking at what point on this is going to be the potential 4 volt. As this 6 volt, the current starts flowing I, and the voltage is going to be distributed between this part and this part such that the sum of these two voltages is going to be 6 volt. And this voltage is going to be distributed in proportion of their lengths. The higher the length, higher the resistance, and you know that R is equal to rho L upon A. So if this so we know that this voltage is going to be 4 volt and this voltage is going to be 2 volts. So if this length is L and this length is 100 minus L, then L divided by 4 will be same equal to 100 minus L divided by 2, because of the division of the resistance. Because the current in this, you can also think it like this, there is same current flowing through this whole wire because the C point has not yet been connected here. So the current here flows I, because of the current, this current I, there is a voltage drop of I into R. I is this I from this point will be V divided by R, and this current will be same here, will be V divided by R, and this voltage across here is 4 volts across 4 volts. So from here from this thinking also we get this relationship. We need to simplify this. 2 into 2 4, so 2 minus 2 into 2 multiplies here, so we have minus 2L plus L is 3L is equal to 2 into 100 200. So L will be 200 by 3 or 66.7. Now part C of this question, Part C of this question asks, if the point C and D are connected by a wire, what will be the current through it? So obviously point C is connected to this point D in this condition. D, when we have found that this voltage to be the same as the voltage at C, and now if we connect it, because there is no potential difference between them, so the current will be 0. And finally, if we are replacing this 4-volt battery with a 7.5 volt battery, what would be the answers of part A and B? Part A asks, what are the potentials at point A and C? So the potentials at A will be 6 volt, but the potential at C will now be equal to 6 volt and minus 7.5 volt or minus 1.5 volt. Now the answer to the question B, at what point of D on the wire AB is going to be the potential minus 1.5. Now the C is at negative voltage. If you look at the distribution of voltage from here to here, it gradually starts from 0 volt. Just next to the B, it is 0 volt. Then it increases to somewhere 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt. There is no way we can reach a negative voltage of minus 1.5 and make the galvanometer read 0. So the answer to that question is, at no point in A, B and B, the voltage will be 0. At the maximum, this one can be 6 volts, so that we can find a null point where the galvanometer reading will be 0 for this arrangement.